Hello everybody, Root Beer here. I thought we'd start another math contest, another Waterloo math contest made by the folks at the Center for Education in Mathematics and Computing. So I thought we'd begin taking a look at the Euclid contest from the year 2002. Now the Euclid is a grade 12 level contest, so in North America that's the highest grade there is in high school, so this is sort of the top tier of high school math contests. It's going to pull together all the knowledge that you've learned so far. And so, you really should be writing this in grade 12, but you are encouraged to practice this if you're, in younger years in high school, and even if you're a very good math student, but even younger than those years. Now, the fact that it's sort of the highest Waterloo competition, the grade 12 competition, means that if you are applying for scholarships at a place like the University of Waterloo, they're going to want to see your Euclid score. So we want to do well on the Euclid contest, get a really good score. Also, it's a matter of pride. We want to really do the best that we can on a math competition. Okay? So we're going to go through question number 1 in this video. But first, let's just take a little bit of a look. So we have the nice CEMC logo up here, and the University of Waterloo. And here are a bunch of people who helped sponsor this particular competition. University of Waterloo, there's SciBase down here, Great West Life and London Life, a whole bunch of folks there helping to keep this contest going. So we have 2.5 hours to do this competition. Calculators are allowed as long as they're not programmable, because you can do a lot of crazy things with a programmable calculator. So there's going to be 10 questions in total in this particular competition. Some questions are broken down into multiple parts. If we scroll all the way down to question number 10, we see it's got A, B, and C. And we also notice that on the side we have some symbols here. This one, this written symbol here beside the B, means that you need to write down a full solution to this particular question. But the light bulb here, beside A, just means that we need a final answer. Now, the way I go through these videos, I'm going to write out my solution to the light bulb question anyway. And if you're doing these contests for real, you have room in your answer booklet to do that, and I encourage you to do so. Because if for some reason you are wrong, and you just fill in the box with your final answer, if you're wrong, you get no marks. If you're right, fine, you're all set. And then they'll mark it correct, give you, 3, 4, 5 marks, and move on to your written solutions. But if you're wrong, and you did leave some work, you did show your work, you can get part marks, as many as 4 out of 5 part marks, that sort of thing. And if we're trying to get a really good score, we want to maximize our potential to get a good score, and give ourselves as many opportunities to earn part marks as we can. Okay? So as I said, we're going to be going through question number 1 in this video, so let's get back there. So question 1 is broken down into 3 parts. We have an A part, which just requires a final answer, B, which just requires a final answer, and a C part here that is going to require a written solution. Okay? So, what does 1A have to say? If M at 7, 7 is the midpoint of the line segment, which joins R, 1, 4, and S, which has coordinates A, 10, what is the value of A? So we want to figure out this X coordinate here. And we're given the midpoint. Okay? Well, fortunately, there's a really nice formula for the midpoint of a line, the coordinates of the midpoint, in terms of the coordinates of its endpoints. Okay? So let's get our notepad out. So if I have a point A, we want black. So if I have a point A and I know its coordinates are maybe, let's say, x1, y1, and I have the coordinates of B, let's say they're x2, y2, the midpoint of AB has coordinates of the average of the x coordinate, or the x coordinates, and the average of the y coordinates. So we know that our midpoint M has coordinates 7, 7. That means that this first 7 must be the average of the x coordinates of R and S. Well, what are those? 1 and A. And this second 7 must be the average of the y coordinates. So average of x coordinates, average of y coordinates. Here we have 4 and 10. And we already over here, we don't need this. We only want to solve for A. But if we just take a look, 4 plus 10 is 14 over 2 is 7. Our formula does work, so we have a little bit of extra confidence here. Now we want to solve for A. Okay. Well, let's rearrange this. So I do A plus 1 divided by 2. The last thing I did was divide by 2. So to try and isolate A by itself, the first thing I'm going to do is multiply both sides by 2 to get rid of that division by 2. So then I'm left with 2 times 7 is 14 is equal to 1 plus A. If I want A by itself, I'm going to subtract 1 from both sides. Whatever I do to one side, I have to do to the other. Subtract by 1 on the right to get rid of the 1 that's on the right. So that tells me that 13 is equal to A. And so if we were doing this for real, we would have our answer booklet and we would put A is equal to 13. And here's our reasoning. And we can move on now to B part. Okay? It's another one involving coordinates of points. So in the diagram, points P with coordinates 3, 2, and Q, which is 11, 2, and R, which is 11K, form a triangle with area 24, where K is greater than 0. Okay, so we definitely know R is above Q, not below Q. That's good to know. What is the value of K? Okay. Well, we're told the area of the triangle. So I'm starting to think of formulas for the area of the triangle, and sort of the most important one is 1/2 base times height. Okay? Well, I noticed that the way our coordinates are set up, and even in their little picture they've noted as well, that this triangle is right angled at Q, which means RQ is going to be a height, PQ is going to be a base. So if we just figured out those lengths, we'd be all set. Okay. Let's redraw our picture. So Q was at 11, 2. P was at 3, 2. R is at 11K. So if we wanted these side lengths here, this is the base, this is the height. Well, to figure out this length here, we're just going to subtract the x coordinates. So this is 11 minus 3, or 8. And this height, well, it's the difference in the y coordinates. How far do we go up? Well, we started at 2, and we go up to k. So we must have gone up by a distance of k minus 2. And we can't simplify that anymore like we did with the 8. Now we know that 24 is equal to the area, which is 1/2 base times height. Well, let's plug in what we know. We know the base is 8, and the height is k minus 2. Okay. Now we can simplify that. That's the 2 and the 8, they cancel out. We're going to get left with 4. K minus 2, or we could say 4k minus 8. And then we could bring the 8 over to the other side. And say 24 plus 8 is going to be equal to 4k. So that's 32 is equal to 4k, and if we divide by 4 on both sides, we're left with 8 is equal to k. Okay. So that's our answer, and once again, it's a light bulb question, so if we just wanted to work out A, we could. but we also have all our extra work just in case we've made an error somewhere. All right, so move on, grab ourselves another piece of paper, and we're going to take a look at C. Now, C does require a written solution. Lines are concurrent if they pass through the same point. The lines 2x plus 3, y equals 8x plus 13, 8x plus 15. So y equals 2x plus 3, y equals 8x plus 15, and y equals 5x plus b are concurrent. What is the value of b? All right. So if they're concurrent, they all have to pass through that same point. So as a picture, what does that look like? Well, we'd have 2x plus 3, y equals 2x plus 3 here. And it would pass through the same point as 8x plus 15. There'd be some point in here, p. And then we'd also have this 5x plus b. Y equals 5x plus b pass through that same point. So let's use these two equations to figure out what our point p is. And then we'll know what point y equals 5x plus b has to pass through. And we'll change our b value accordingly. So to figure out a point of intersection between two given lines, we set them equal. Okay. The p-value that they have in common has to have the same x value and the same y value. So their y values must be equal. And so for the same x value, this equation must be satisfied. And now we can rearrange this. We can bring the minus 5 on this side, get rid of the 5 over here, and have 8x, and bring the 2x over to the other side as minus 2x. 3 minus 5, that's negative 2. 8x minus 2x is going to be 6x. Or we could say minus 2 over 6 is equal to x. Or really, x is equal to negative 1/3. So now we know the x-coordinate of our point of intersection. And we can plug it into either one of these lines, we'll do it with the first one, to figure out what the y-coordinate of our point of intersection is. So negative 2/3 plus 3. Well, I don't really like 3 here. I can't add it to my negative 2/3, so I'm going to give it a common denominator. 9 over 3 is the same as 3. So now I can say 9 minus 2 over 3. Or really just 7/3. So negative 1/3, 7/3 is our point of intersection. And if we wanted to, we could double check that our arithmetic in the first part, solving for x, was correct by making sure that this same point is actually on our other line. Okay, negative 8/3, and then we'll change that to 45 thirds. Something has gone amiss. Oh, that's why. This should be 15. I copied it wrong. Okay. So it's good we did that little check. I screwed up. So we'll bring that 15 over there. That becomes negative 12. Negative 12 over 6. So it actually should be x at negative 2. Look at that. Double checking our work actually helped us out. So let's see. 2 times negative 2. Well, that's actually just going to be negative 4. And then we add on 3. And we get negative 1. So actually our point of intersection should be negative 2, negative 1. And once again, we're going to double check, because maybe I've made another mistake somewhere. we're going to check that this point is on the other line as well. 8 times negative 2. Well, that should be negative 16 plus 15. And that's definitely going to be negative 1. All right. So we definitely got the right point. So now we know y equals 5x plus b must pass through negative 2, negative 1. Okay. So that means negative 1 is going to be the y-coordinate, and that's going to be 5 times the x-coordinate plus this b value, and b is exactly what we want to determine. So negative 1 is equal to, well, what's 5 times negative 2? That's negative 10 plus b. We can bring the 10 over to the other side. We get 10 minus 1 is equal to b, or b is equal to 9. And if you wanted to, you could make a little therefore statement. Therefore, in order to make all three lines concurrent, b has to be 9. You can say something like that if you want to. But we've shown all our work. We got our point of intersection. We did a little double check, and thank goodness that we did. Once we found our point of intersection, our point of concurrency, we then said, okay, well, this other line, 5x plus b, has got to pass through that point, and that allows us to determine exactly what b is. Okay, so that's a nice first question on the 2002 Euclid. We're going to look at question number 2 in the next video. So thank you guys for joining me, and I hope to see you in the next video. Until then, have a wonderful day.